How's it going, everyone? So today we're going to have a look at the Blockchain Trilemma. Now, the Blockchain Trilemma is a concept that was brought up by the Ethereum co-founder Vitalik Buterin. The Blockchain Trilemma states that all blockchains must balance between three variables, specifically decentralization, security, and scalability. So all blockchains must balance between these three variables. So they must prioritize two of the three. So blockchains like Bitcoin have prioritized decentralization at security, but then this comes at the expense of scalability. Then you've got blockchains like Solana, which have prioritized scalability, but are not very decentralized. All right, so we've got the blockchain trilemma. It comprises decentralization, security, and scalability. Now, decentralization is the number of full nodes participating in the network. So the number of validators that verify transactions and add new blocks to the blockchain. So the more nodes, the more decentralized it is. So a variable that affects the decentralization is the hardware requirements. If you need fancy computers to run a node that have high computing power, that is inherently expensive. And because it's expensive, not a lot of people can afford to do it, right? And that'll make it that there are less validators and therefore more centralized. Then we've got validator selection. So random selection is more decentralized. So if we look at proof of stake, for example, this is a random decision of who becomes the next validator. Then you've got something like delegated proof of stake, where the founders or the founding team decide who can be a validator, right? This would make the system more centralized because there is a central authority who decides who gets to be a validator, and the entire network will be less decentralized. The last one is governance model. So community voting equals more decentralization. So if updates to the blockchain are done by the community, so they decide what updates are made, that would make the entire blockchain more decentralized. But if there is a founding team that makes every decision about the blockchain, then we've got a more centralized blockchain. All right, an example of a highly decentralized blockchain would be Ethereum and Bitcoin. Next, we've got security. So the security is the amount of resources required to corrupt the network consensus. So how much effort do you have to put in to beat the security of the blockchain? So some key variables, the first one is consensus mechanism. So proof of work versus delegated proof of stake. In proof of work, you would have to control 51% of the network in order to make a false transaction. And in the case of Bitcoin, there's over 1 million validators, so you would have to run, or miners actually, so you would have to control more than 51% of these mining pools, which is very much not feasible. Then we've got delegated proof of stake in comparison, where the founding team decide who get to be a validator, right? So if they pick only people that they know, they can very easily coerce with each other and decide which transactions to approve and which not. Then we've got block finality time. So the faster the finality, the less security there is. So in the case of Bitcoin, for example, a block takes quite long to be added. This is because there is like network consensus between all the blockchain, between all the nodes, and this makes it for a more secure network. Then the number of validators. So more validators equals a stronger security. So if you think about it, let's use Ethereum, for example. Ethereum has got just under 1 million validators. So all of these validators are communicating with each other, and to have 51% control of the network is very difficult because there are so many validators. This is unlike Solana, for example, which has only got 1,500 validators. So for them to coerce with each other and corrupt the blockchain is a lot easier. The last one is the cryptographic algorithm. So stronger cryptography increases security. So in the case of Bitcoin, for example, the difficulty of that hash, so that math problem that you need to solve, dictates how much computing power you need, and therefore how much more expensive it is to actually beat the blockchain, right? So to cheat it. The last one, all right, Ethereum and Bitcoin are also highly secure. The last one is scalability. Now, scalability is the number of computations the network can run per second. So how many transactions can happen per second? So key variables here is the number of validators. So if there are less validators, it is highly scalable. So all the validators need to communicate with each other, right? So if you've got 1 million validators that need to communicate with each other, this takes super long. Whereas something like Solana that has only got 1,500 validators, the communication is quick and they can add transactions quickly. If you think about it in like a company sense, if you've got a new company with 5 people in it, they can make decisions very, very quickly. But then if you've got a company with 1,000, 10,000 employees and 100 people in the management team, the decisions take a lot longer. So it's very similar to blockchains. Then we've got block time. So shorter time equals faster transactions. And then the last one is block size. So if the blocks are larger, so for example, Bitcoin at the moment is 2 megabytes per second. 2 megabytes. If you increased it to 4 megabytes per block, then the scalability would essentially be double that. So that is a variable that you can change to increase scalability. Now, an example of a scalable network would be Solana or Ethereum layer 2s. Alright guys, and that's it for our video on the blockchain trilemma. Just a note that there are efforts being made to overcome the blockchain trilemma, such as Ethereum's sharding and the layer 2 scaling solutions. If you guys got any value from this video, definitely give it a like and subscribe to the channel.